Starting. There we go. We are now live. So let's just go through this. I'll answer one, then you answer one.
Okay.
And we'll see if we agree. So, question 2. In an article of the Journal of Small Business Management, successful startup businesses in the United States and Korea were compared. One set of data compared education level, high school, undergraduate degree, master's degree, doctoral, of people who managed successful startup companies in the United States and Korea. You want to determine if education level of managers of successful startup companies is independent of the country they are from, United States and Korea. Which hypothesis test would be most appropriate for this analysis? And I believe it's the chi-squared test of independence, the last one.
Yes, I do agree.
Okay. Go
Because,
ahead with question 3.
because at first I thought it was like a Nova test. That's why I thought at first.
Yeah.
A human resource manager report data from its interesting resource and force RIF at her company. You're an attorney. Wants to the eight expression what's a factor. It's illegal to employ because of a the company reports the number of employees in two groups: 40 years or older or younger, and over 40 years old. There also report the number of employees in each group was terminated both age groups were terminated equally. What's a high prospect will be for this analysis? One, two, the test of two articles.
Which one?
The test of two particles.
Of two proportions?
Yeah, the two portions.
No, I believe it's the independent sample t-test.
Okay.
Because we have two groups that are slightly related, and we're checking. It's not quite proportions that we're going over. So, all right, question 4. A survey was conducted by a group of state lotteries. A random sample of 2,406 adults completed the survey. A total of 248 were classified as heavy players. Of these, 152 were male. You want to determine the proportion of the male heavy lottery players is different from the proportion of males in the population, which is 48.5%. Which hypothesis test would be most appropriate for this analysis? And I chose the test of one proportion.
I chose the test of two portions.
Okay. Why?
It's talking about the males, like, because the heavy players and the male. I thought they were different groups.
They're definitely a subset of the group. Let's see. So if we were to do two proportions, we'd need two x's and two n's, and we wouldn't have a null hypothesis, right?
Right.
And we could force those. But we have one obvious proportion, which is 152 out of 248, or 248 out of 2,406. And then we also have a null hypothesis of 48.5%. So the random sample just kind of tells us how we get our actual sample of heavy players. And so it's a 1 test because we do our X would be 152, our N would be 248, and our null hypothesis is 48.5%.
Okay,
All right?
sounds good.
Okay.
Am I on number 5 now?
Yep.
A standard project compares the effectiveness of 2 different combination lockers. One of these locks turns clockwise first, and the other lock turns counterclockwise first. That asks 25% in the study. Each student went a proportion to each lock and asked to open the lockers. The time that took them to each lock was reported. They want to determine which lock was easier to open. Which property test is most appropriate for this analysis? The pair example t-test.
I agree. All right, for the next 3 questions, identify the one confidence interval that is most appropriate for the given situation. A bank employs 2 appraisers. When approving borrowers for mortgages, it is imperative that the appraisers value the same types of properties consistently. To make sure this is the case, the bank evaluates 6 properties that both appraisers had recently valued. Which confidence interval would be used or would be most appropriate for this study? I went with C, paired samples, T confidence interval.
Yes.
Okay.
In a Wall Street Journal article, surveys the career path, the percentage precisely major reports were significant. The career path was reported. The same data was also reported for county managers. Confidence in 95 confidence interval to see the standard difference significant. Which confidence interval would be appropriate for this study? I choose the last one.
Confidence interval for 2 proportions?
Yes.
Let's see. And
Am I right?
I think it's an independent samples for T confidence interval.
Okay.
But I could be wrong. So give me a moment. So let's see. Could it could be the confidence interval for 2 proportions though. Let's see, what do we have? We don't have a lot of data. We just know we have 2 populations.
There's a county major and psychology major.
I would say it's the 2 sample t-test. No. No, you're right. It would be the confidence interval for 2 proportions.
Yay, got one.
Yeah. So the reason why you're right is because this is a qualitative test. Satisfied doesn't come with a number. You can't plug in numbers 1 through 10 or anything that mean anything with people being satisfied. So it would have to be a proportional rather than a other one, right?
Right.
Okay. All right, question 8. Double stuffed Oreo cookies are supposed to have twice the filling of regular Oreo cookies. You and some friends decide you want to know if this is true, a true assertion by the company who makes them. You take a sample of 55 double stuffed Oreo cookies and measure the amount of filling in each one. You need to construct a confidence interval to estimate the true mean filling amount of double stuffed Oreos in order to compare it to the filling amount in regular Oreos. Which confidence interval would be most appropriate for this study? I think it is the one sample t confidence interval.
B.
Yeah,
And that's what I chose.
okay. All right, then let's move on to question 9.
Which one of the following best define the significance level of the hypothesis? I choose B. The probability of type 1 error.
Let's see. And a type 1 error has to do with the null hypothesis, right? Well, they both have to do. Every time we go over this, I forget the difference between type 1 and type 2 errors. So,
I think this is from session 2.
yeah, so the one is rejecting falsely the null hypothesis. So, yes, I believe you are correct. Okay, which one of the following best defines the notion of p-value of a hypothesis test? The probability of the type 1 error, the probability of the type 2 error, the probability of observing a sample statistic more extreme than the one actually obtained, assuming the null hypothesis is true, or the probability of rejecting H0, whether it's true or not. I believe the answer is C.
That's what I chose.
Okay, let's move on.
Suppose you create a 95% confidence interval for the mean and given 10 to 20. You've been told to report this as saying something like, we're confident that the true mean is between 10 and 20. That's what this means. I just believe.
Hold on a second, I need to go turn off the oven.
Okay.
Have an alarm beep. All right, I'm back.
I just believe.
I believe you are correct. Okay, use the following information to answer the next 3 questions. Hooray. Need to clear this off. Okay, you take a simple random sample of 100 adults from a town in the western United States to determine the proportion of those in town who invest in the stock market. Assume the unknown population proportion or percentage of people in town who invest in the stock market is P is equal to 0.30 or 30%. Okay. What is the mean distribution of the sample proportions? What is the mean of the distribution? Let's see.
Is it 0.3?
I think you're right.
It's about 50%.
Um,
Number 13.
yeah. Okay, so we're right with question 12. It is 0.30. What is
Okay.
the
What is the standard deviation of the standard sample portions? I got 0.046.
That is what I got as well.
Okay. That took me a while.
Okay, what is the probability that your random sample of 100 adults will have a sample proportion less than 0.25? I believe the answer is 0.876.
Are we on question 15 now?
Yes.
Current panel means control, I turn and control trials. 2,142 subjects were divided into two groups. The 1,560 subjects experimental groups received the 579 subjects or control groups receive placebo and of the 1,560 experiment groups, 61 dizziness of side effects. Of the 579 subjects in the control group, 15 received as side effects that P1 be the true portion of people outside dizziness that taking petrol that P2 be the true portion of people who exercise who experience dizziness but not taking Paranol. What is the margin of error for the 95 confidence interval? Round to 3 decimal places.
Okay, I got 0.013.
0.1043.
No, 0.013.
Okay. Oops, sorry. Okay.
Circled one right there.
Okay. And put the lower bound.
What did you get for that one?
I did not work on this part at all.
Okay. Do you have your Excel sheet opened up?
No, I did not. I was looking to open. I was looking for that one at the very top, but I was not. I was finding the PLEU stores, AM/PM heights, the very top.
Yeah, no, you'll need to open the categorical data analysis underscore hat Excel file that we've been using for a lot of these.
Do you know what lesson was that on? That's how I get to it.
Let's see. I think we started using this one on lesson 17 was our first time using this one. Might have been lesson 16 actually. Yeah, lesson 16 is.
Oh, okay, wait, I don't see it. I don't see it. Is it the no click?
It is on lesson 17.
Lesson. I was on lesson 16.
Yeah, lesson 17 under 2.3.
Okay. Two point three. There it is. Okay. Tell me if I'm correct. Number 18. Okay. Let's do that one. Okay, that is. Where is it? Show all. Show in a folder. Open. Come on, open. Save. Oh, I do have it open. Is it a one example t-test for the means?
No, if you have the t-test one, that's the wrong one. You want the categorical data analysis.
Is it the top one?
No, it's the third one. Categorical data analysis underscore hat .xlsx.
Now I have to open up. Okay. It is the one particle, the two particle, the chi square.
It's the two proportions.
Okay. what do I put in?
Just the numbers from the question. This is how it's ended up working out. Just as you read from the question, our X1 was 16 or 61. 61 of the first group had dizziness. The total size of the first group was 1,563. The number in the second group who experienced dizziness was 15, and the total number in the second group was 579.
Is it the conference? Is it like P less than P2?
The confidence level and the type of test don't matter, or the confidence level is 0.95, but the type of test doesn't matter because we're not asked any questions about that, and we're not given any information.
Okay. Yeah, nice. Am I thinking the negative 0.003?
Yep, that's our lower bound.
In the upper bound, it is 0.029.
Yep.
And it's A, 18.
18, I haven't done yet. So, all right, I'll read this one. Perform a hypothesis test to see if the proportion of the experimental group of subjects who experience dizziness is different than the proportion of control subjects who do. Use a level of significance of 0.05. What are the appropriate null and alternate hypotheses? Yes, A is correct.
Okay.
So now that gave us our 0.95 confidence interval, and for our type of test, we want P1 not equal to P2 in our Excel program.
Is it 1.458?
Yep. And then the p-value of your test is 0.145.
.145?
Yep.
Okay.
All right. Your turn to read question 21.
Is there significant evidence to conclude that the 2% of people who exercise dizziness were taken apropos is different than the 2% of people who exercise dizziness is not taking apropos? Yes, I failed to reject the HO.
It's no. I failed to reject the H naught.
Is that?
Is there? Yeah, it's the last one. A, B, C, D, E, F.
A, B, C, D, E, F.
Okay. So is there sufficient evidence to conclude that it's different? No, because we didn't reject the null. Okay, information. Use the following information to answer the next 4 questions. A survey was conducted of 1,279 random selected adults aged 18 and older. They were asked, are you a morning person or a night person? The hypothesis for this study are H naught, being a morning or evening person, is independent of age, and H alternate is being a morning or an evening person is not independent of age. The results of the survey are given here. See results. Conduct a test of independence. Use the level of significance of alpha equals 0.05. So now we're going to use the chi-square tab on our Excel spreadsheet.
Is it 0.580?
For our test statistic,
Yes.
give me a moment. I'm going to need to plug all this in still.
Okay.
All right, what did you think the test statistic was?
6.580.
I got 6.579.
Do we round up?
No. Unless, no, we shouldn't. So 6.579.
And the p-value, I got 0.87.
0.087.
8.
Yep.
Okay. 0.087.
Yep.
Okay.
Okay. Should you reject H naught? No, the p-value is greater than 0.05. D.
A, B, C, D. What do you prove based on your results? So it's the morning, it's 3 out of 4. They're morning people. I think it's A. It's not A. It's not D. I think it's D for boy.
It's D for Delta or dog.
Okay.
Because we kept our null hypothesis, and if we scroll back up to the information, our alternative hypothesis is being a morning or evening person is not independent of age. And so we have insufficient evidence of our alternate hypothesis. Is how it's written out, so it's D.
Okay.
All right, 26. A recent book noted that only 20% of all investment managers outperform the Dow Jones Industrial Average over a 5-year period. A random sample of 200 investment managers, let's see, so, that had graduated from one of the top 10 business programs in the country were followed over a 5-year period. 50 of these outperformed the Dow Jones Industrial Average. Let P be the true proportion of investment managers who graduated from one of the top 10 business programs who outperformed the Dow Jones over a 5-year period. Based on the results of the sample, create a 95% confidence interval of P. Input the lower and upper bounds below, rounded to 3 decimal places. All right. So we're back on to one proportion. Our x is 50. Our n is 200.
Okay, okay, now I had to give. Okay, x is 50, and example size is 200. And 200.
Yes, n is 200.
And the confidence level is 0.95. And the null hypothesis that is, where's the null? Where is the null hypothesis?
So our null, we actually have to calculate ourselves because, wait, let me,
Do we? Because I'm getting a lower bound of 0.190, and my upper bound is 0.310.
yep, that's what I got as well for those two. All right, suppose you had been in charge of designing the study. What sample size would be needed to construct a margin of error of 2% with 95% confidence? Use the prior estimate of P star equals 0.2 for this estimate. Okay. This is a good review because I don't remember going over this part.
Is it that we're taking from lesson 2, 1.96? I'm just guessing, okay?
Let's see. Oh, I just wanted to find what's up there. Okay. So we want margin of error 0.02 and our z-score for the 95% is 1.96. And our P star is 0.20. So we do our 1.96 divided by 0.02 squared times by our P, which is 0.2, multiplied by our 1 minus P, which is 0.8. So that's the equation we get there at the end.
Okay.
All right, do you see how that's done? Our Z naught over our desired margin of error squared times by our P times by our 1 minus P.
Okay, 1.96 divided by 0.02 minus 0.3 Is it 1,536.64?
1,536.64 is what you got?
Yes. Yes.
Yeah, but we rounded up to the nearest whole number because we want to use whole people.
Okay.
1537.
Do we put the 3 decimal places still? The 000?
Nope, because you don't talk about using point zero or point anything of a person.
Because I just want to make sure, like something you need to put, if it's 50.0000.
Yeah, no, just 1537.
Okay. Number 29.
All right. Suppose you wish to see if there is evidence that graduates from one of the top 10 business programs performs better than other investment managers. Conduct a hypothesis test using the level of significance of alpha equals 0.05. Which of the following pairs of hypothesis tests would be of hypotheses is the most appropriate for addressing this question? And I have E. H naught is P equals 0.2, and HA is equal to P is greater than 0.2.
See. What are the requirements from the FEMA to ensure that the P hat is normally distributed? Is it all of them? I think it is A.
Yep, it's A. All right, the value of your test statistic is, I got 1.768.
1.768. 1.768.
Yep.
Where are those numbers coming from?
From our Excel spreadsheet. The test statistic is our Z.
Is it the one example?
Yeah, it's the one proportion. It's the same one we've been. It's the same one we use to get our upper and lower bound. Should be that same number.
Is it this one that we're using?
Let me pop open. Yes.
Okay.
And you want to be sure to, let's see where. So our null hypothesis is the 0.20, and the type of test is greater than.
It's number 20. Okay, down is okay. Okay.
So our Z value is 1.768, and our P value is 0.039.
0. Okay. 0.039. That's the P value. Okay, and the seems evidence that graduates from top 10 business programs perform better than other investment managers. Let's see, I say yes.
Okay.
I failed to get the HO.
No, we did reject the H no, so we're accepting the hypothesis.
The 8.
So it's A. I
Okay.
I think. Or actually, I think it might be C, D, E. E.
Mm.
That's
And number 34.
hold on a second. I think it is A. Yes, we rejected H naught for 33.
Okay.
All right. So 34. Computer software is commonly used to translate text from one language to another. As part of his PhD thesis, Philip Cohn developed a phrase-based translation program called Pharo. The quality of the translation can vary. A good translation system should match professional human translation. It is important to be able to quantify how good the translations produced by Pharo are. The IBM T.J. Watson Research Center developed methods to measure the quality of a translation from one language to another. One of these is the bilingual evaluation understudy. A blue score is a number ranging from 0 to 1 that indicates how well a computer translation matches a professional human translation of the same text. Higher scores indicate a better match. Blue helps companies who develop translation software to monitor the effect of daily changes to their systems in order to weed out bad ideas from good ideas. To complete Pharo's ability to translate with similar computer translation software, Cohn took a random sample of 100 blocks of Spanish text, each of which contained 300 sentences, and used Pharo to translate each of these to English. The blue score was calculated for each of the 100 blocks. These scores are recorded in the data file bluescores.xls. He wants to use this data to see if his mean blue score differs from the mean blue score of another leading translation software, which has a population mean score of 0.295. Assuming the requirements are satisfied, construct a 95% confidence interval for Pharo's true mean blue score. Record your answers below. Okay, that was a lot of information.
Yes.
So I'll open up our blue scores. Boom, boom, boom.
Is it the one sample t-test?
I believe so.
Because it's going. I think it's going back to Records 12. I'm guessing. It's lesson 11.
Yeah, the one sample t-test is the one that makes the most sense.
Okay, let me see that one. That's not that one. Do you have to open a narrating up? Let's see, not that one. It's the first one. Show all. Show the full. Let's see. Alright. Where is it? $100. Is it okay? I have it in already. Is that what yours looks like?
Um, that is not what mine looks like. I think you're using. Are you using the one sample T test? Or
I'm using the HISTO
the histogram and descriptive stats?
Yes.
Yeah, that's the wrong Excel file that you're using.
Okay.
You want to use the quantitative inference procedures Excel file.
Is it the second one?
It's a great question.
Because it's going back and forth, back and forth.
Yeah. Give me a moment. And yes, it's the second one.
Okay. Oh, I just. The confidence level for the load balance is 0.282.
Yep.
Okay, how can I just copy and paste? Save. And the next one is. And another one is 0.293.
Yep.
And the degrees of freedom. One is Or it's 99.000.
Yep.
And let's see if we go back. And it's negative 3,683.938.
No. You'll
No.
want to change the value of your null hypothesis and your type of test.
Okay. To 100.
So in the information above question 36, it says our H naught is 0.295. So 0.295.
Is that the null hypothesis?
Yeah. 0.295. The information just above question 36.
I could just copy and paste that part. I need to change the test level.
So the type of test is not equal to.
No. It's negative 2.803.
What was that, Brett?
It's negative 2.803.
Yep.
Copy that part. Save. And do we have to round up like 0.06?
Yeah, you round to the nearest, so it's 0.006, yeah.
Okay, and number 39. Based on the results of the test, what do you clue using a level of confidence of alpha equals 0.05? We have insignificant evidence that the true mean is equal to 0.295b.
We have sufficient evidence to say that the true mean is different than.
Okay.
Because that was our test. It's not equal to 0.295. Because our p-value is small, we can say it's sufficient evidence. Information. Use the following information to answer the next 6 questions. A study was done to test the notion that people are taller when they first wake up in the morning than the evening right before they go to bed. To test this theory, the heights of children in a boarding school in India were measured. Values were recorded in millimeters for each child in the morning, and again in the evening. The data is recorded in AM/PM heights. You want to determine if the children are taller in the morning than the evening. Define the differences as AM minus PM height. Construct a 95% confidence interval for the true mean of heights and conduct a hypothesis test to determine if children are taller in the morning than in the evening. Put in your answers below.
Is this the paired example?
Yeah, paired
T-test
sample
mean?
t-test.
Delete. So what are they? One. Is it 8.728?
Yep.
Okay. Now it's 8. Why is it not? And the next part, the top page. Oh, great. Just is it 10.455?
Yep.
Okay, and 22.446 for the test.
Yes.
What is it? I think that piece. I think 22.446. And then the degrees of freedom. 40.
Yep.
And put the piece back to the test. How do you do that? By 2.79.
It's 0.000.
Is it because of the E minus 24? That's why?
Yeah.
Based on this field, the sample test that doesn't hold anymore in the evening. I'm saying no because we reject the no.
It's yes because we rejected the null. So C as in Charlie.
Okay.
All right. So we did get a few wrong.
Oh, it's one. I have not yet.
Don't submit yet. So go up to question 3. I might have accidentally messed this one up on my own. We might have had it right before. What do you have as your answer for question 3?
On D?
You have D for question 3?
Yes.
Okay. Yeah, no. That's what I had as well, and it is incorrect. I've submitted already. So a human resources manager reported data from a recent involuntary reduction in force at our company. You are an attorney and you want to determine if age discrimination was a factor. Okay. The company reported the number of employees in 2 groups, 40 years old or younger and over 40 years old. They also reported the number of employees in each group who were terminated. You want to determine both age groups were treated equally. Which hypothesis test would be most appropriate for this analysis?
the test of the two portions. No,
I think it's the chi-squared test for independence, now that we reread it.
that's almost same like question 2.
What's that?
That's almost same as question number 2. Same answer.
It is. Let's see. So let's talk through this. So we have two groups, 40 years or younger and over 40. They have the number of employees in each group that were terminated, which is a qualitative, not a quantity. Okay, so if two proportions, that might be right. Let's. Yeah, the test of two proportions. I think you're right.
Okay.
So.
That's the A, B, E, F. 7.
Yeah. And then question 15.
Is 16 correct?
16 is correct, but 15 wasn't. 15 should have been 0.016, not 0.013, I believe.
Okay.
And then question 14, we also got wrong. They'll need to do replug in information for that one.
E.
Okay.
E. So, and then where's the
Let's see.
Got you. Yep, 0.2 pound.
Okay, I think the answer for 14 is 0.138.
Okay.
So 0.138.
Okay.
All right. So go ahead and